Find the vertical asymptotes. When we have the polynomial function, finding the vertical asymptote, the first step is we have to factor px and the q of x and remove any common factor. Step 2, set the denominator equals 0, and from there you solve for x. So you have to get the simplest form of your rational function, and then you set the denominator equals 0 to find the vertical asymptote. And this is the same step when you're finding the domain of your rational function. But the domain, we use the interval notation to represent it. Vertical asymptote, we use the equation x equals something to represent it. Now we do the practice here, finding the vertical asymptote, if any. So here, when I look at the rational function here, I know there's no like term we can reduce. So we can just set a denominator here equals 0. So I have x squared minus 16, set that equals 0. So x squared equals 16, that means x equals positive negative 4. So these 2 points turn to your vertical asymptote. So the 2 vertical asymptote at x equals 4 and x equals negative 4. We do the example B. G function has x minus 4 over x squared minus 16. Let me change another color. So when I look at the function, I realize the bottom part here. The bottom part we call it the binomial form. So when you have the binomial form, both of the terms, they come with a perfect square. For example, x squared minus 25, x squared minus 100, x squared minus 49. So 25 is a 5 square, 100 is a 10 square, 49 is a 7 square. And you have the minus sign in the between of both of the terms. We call this as binomial factor form. In that case, we can rewrite these 2 terms into the x plus 5 multiply x minus 5. Same way with this one, x squared minus 10 squared, you can rewrite it into x plus 10 multiplied by x minus 10. With this one, you rewrite the form into the x plus 7 multiply x minus 7. The reason why we need to get the factor form because there is a like term we need to reduce before we find the vertical asymptote. So the bottom part here, I can rewrite into the x plus 4 multiply with x minus 4. If you use a FOIL to distribute back, you will get x squared minus 16. Now, we have x minus 4 here. So I can cross out x minus 4. Now this point, it didn't go away. It will turn to an open circle on the curve. So the open circle on that curve, we will have x equal 4 and y equal 1 over a of the location of the point. We will do that part on the next slide. So now once I reduce the x minus 4, the remaining term I have here is 1 over x plus 4. Now we can find the vertical asymptote. So we set the denominator equals 0. That means x equals negative 4. So the g function only has one vertical asymptote at x equals negative 4. Do the h of x. This function we cannot reduce, right? So the only way we can do is set the denominator equals 0. So when I bring the 16 to the right hand side, it turns to the negative 16. Now we do the factor form from here, do the square root. Sorry, we do the square root, not a factor form. Take the square root on both sides, we will get the positive root negative 16. So that means your x equal plus minus 4i. Now keep in mind, I is imaginary number. We cannot find this point on your x-axis. So in that case, your h function, no vertical asymptote. Even although we solve for it, but this number is a non-real number, we cannot take it. So there's no vertical asymptote for your example C. Okay. Now if you go back to the g function we just did earlier, we cross out the x minus 4 equal 1, right? It cross out. These two reduce. This point didn't go away. It turned to a 0. It turned to an open circle on the curve. At that point, at that coordinate point 4, 1 over 8. The way I getting the 4 was because you're x minus 4. So x minus 4 set that equals 0, that means x equals 4. After that, you substitute this 4 into this part. So 1 over 4 plus 4 is 1 over 8. So that means when you come to that location, 4, 1 over 8, you will find an open circle on the curve. In other words, at that point 4, 1 over 8, the function will discontinue. So at that point, you will see an error on your calculator. If you go use a calculator to see the function, okay, you cannot find the y value at that point. Although we know the y value is at 1 over 8, but technically we say that point is discontinued because the open circle there. So this is information just to let you know. When there's a one term that reduce from the top and the bottom, it turns to an open circle on the curve. It didn't go away. Okay. Now we move to finding the horizontal asymptote. Finding the horizontal asymptote, we need to compare the highest degree power and the lowest degree power. So function f of x is a p over q, and I rewrite it into the a times x to the power n plus over bx power n plus So the m and the n represent the highest degree power term of your polynomial function. Finding the horizontal asymptote, we need to consider 3 different conditions. The first condition is when the highest degree power on the top is less than highest degree on the bottom. For example, you have x power 5 over x power 7. So 5 is less than 7. In that case, your horizontal asymptote y is equal to 0. So you will have the horizontal dashed line passing through y equals 0. The second condition is when m is equal n, then the horizontal asymptote at y equal a over b. For example, you have 2 x power 5 over 3 x power 5. So you have the highest degree power on the numerator is equal to the highest degree power on the denominator. In that case, 2/3 will turn to the horizontal asymptote. When highest degree power on the numerator is greater than highest degree power on the denominator, in that case, there's no horizontal asymptote. It has a slim asymptote, but the slim asymptote is not a topic we will cover in this section. So you just recognize when m is bigger than n, then no horizontal asymptote. We do the practice of this one. Finding the horizontal asymptote, if any. So we compare the highest degree power on the top, which is 1. The highest degree power on the bottom is 2. So since 1 is less than 2, so your horizontal asymptote at y equals 0. Highest degree power on the top, this is 2. The highest degree power on the bottom is 2 as well. So they are equal. Then we just take the coefficient number of your x squared term, which means the horizontal asymptote at y equals 3 over 1, which is 3. The highest degree power on the numerator is 3. The denominator has highest degree power is 1. So 3 is bigger than 1. In that case, no horizontal asymptote.